So what is Kotlin? Kotlin is a programming language created by JetBrains, and JetBrains is pretty much a IDE creator. What an IDE is, it's pretty much a fancy text editor, much like Microsoft Word or WordPress for programming languages. You need these editors because imagine trying to create a paper without WordPress or Microsoft Word. It would be very hard to do that in Notepad. These create the features to create these apps much faster. Kotlin runs on the JVM, which is the Java Virtual Machine. That pretty much means that Kotlin, in a very basic sense, Kotlin is Java. Now, Kotlin isn't exactly Java, it converts to Java, but we're trying to describe this in a very basic way. Let's just say Kotlin is Java. So why not learn Java instead? Kotlin was created for the features in mind and to make it very easy to use. With this, for creating Android apps, it's usually known to create them with Java, but now a lot of people are creating them with Kotlin instead, and actually companies are converting their Java apps to Kotlin, mainly because of the ease of use that Kotlin has. Very fun fact, Kotlin Island is what it's named after, Kotlin, and it's near St. Petersburg, Russia. Before we get to use Kotlin, we need to download a few tools. In the last video, I said that Kotlin is pretty much like Java, mainly because it uses Java and uses the Java Virtual Machine. So we need to download Java's development kit. Just do Java JDK download in Google, and we go to the Oracle website, and yes, Oracle owns Java. You just press download on the JDK here, and then pick your operating system. If you're a Windows 64-bit, you would download the 64-bit. If you were a Linux 64-bit, you would download the 4-bit. The next thing we have to download is IntelliJ's IDE. Remember last video I said that IDEs are what JetBrains is making, and this is a IDE from JetBrains. This is going to make the development a lot easier for you guys. So just in Google, just put IntelliJ download, or Bing, whichever one. I guess Google Chrome wants me to use Bing instead. So we go to the JetBrains website. Make sure you download IntelliJ IDEA. IDEA is our Java and Kotlin IDE. Let's download. Then press here whatever operating system you have. Whether you're Linux, Mac, or Windows, just download that. And go through the setup instructions, and you should have something very similar to, let me present it on the screen right now. This is what you should be seeing on the screen when you first start up IntelliJ. Now we're going to create our very first Kotlin project. The first thing you need to do is open up IntelliJ and then create a new project. Now don't go to Kotlin and then Kotlin JVM. You want to go to Gradle, because then if you go to just Kotlin, you won't have the certain features you need. Go to Gradle and then click on Kotlin Java. Your artifact ID is pretty much your project name. Let's do this tutorial 1. And I think we're fine here. And we're also click finish. Your project is going to pop up and it's going to say tutorial 1. The first thing you want to do is you want to generate an Ant build You don't need to know exactly what this is, just know that you have to do it. When that's done, we have to create a few files now. On tutorial 1, just right click and do new. Now do directory. Put in source. In that, create a new directory called main. And now add your Kotlin. All of our Kotlin files that have Kotlin code in them are going to be inside Kotlin. So if we go to new and then Kotlin file class, we're going to have our very first Kotlin class. And that's how you create your first project. We're now going to create our first Kotlin code. First thing, we need to create our first Kotlin file. We need to right click Kotlin, new, Kotlin file / class. You create your Kotlin file. Now we're just going to put first tutorial. And now I'm going to create something, and you don't need to know exactly what it means yet, but just know that this is a block that will run our code. What this is this fun is short for function, and this function main pretty much is a starting point. It's what runs your code. So within these brackets, that is where your code is going to be. That's going to be running. So whatever you put in here, when you start the application, that's going to run. So we're going to have something print on the screen, and it has to be within the main function. We're going to do a print line function. What this is print ln. Ln is short for line, and this is a function, and you know it's a function because it has these parentheses. What these parentheses mean is that this is the function name, and this is where your arguments go. So whatever you want. So the first argument, if we control space on print line, we can see that if we scroll down to print line, we have print line and a message. So you see these parentheses. Well, that's very familiar. These parentheses, it's saying that we need a message, and that's it. We need that as a character. That means we need it as a string. You don't need to know exactly what a string is yet, but just know a string is pretty much text. So we do need to put in one thing in here, and we're just going to put in hello there. Now if we click this Kotlin logo here, we left click it, press run, we can now run our code, and whatever inside of here is going to be running. So our print line is going to show hello, like right here, as hello there. We now just ran our first Kotlin code. Now we're going to do some very light math. So in the print line, we're going to print out the math. So 2 plus 2, very easy. We're going to get 4. But we can also do things like multiplication. We can do 2 times 3, and we can do that times with a shift and 8. Play that again, we should get 6. We can also combine things with parentheses, so we can do 2 plus 2, put that in a parenthesis, and we'll get 2 plus 2 equals 4 times 3, which is 12 now. Yep, we got 12. We can also do things like multiplication. We can do 12 divided by 6. we'll get 2. And we can also do things like modulus. If you don't know what modulus is, it's the parentheses. We'll do a 5. So we'll get the answer from this, then I'll explain it a little more. We'll do a more of an example another time. So we have 2. Maybe thinking 2, why is that? How we get that 2 is we do 2 12 divided by 5, 2. But also a way that I do it is how many times does 5 go into 12? And that's 2, so you get 10. And then you take the number 12 and you minus that. And that's how you get that 2. But now, what if we wanted to combine things? What if we don't want to have this in our print line? What if we have things like times 2 plus 9 minus 12 times 42? It gets to a big giant lamb numbers, and it starts getting turned to a lot. So that's what variables come into play. Variables are very much like boxes. They hold things. And make a variable, we can have something like val. We can have question 1 equals 12 modulus 5, right? That's 2. I'm trying to this a little easy. So we'll do the print line first, and then we'll verify with the variable. We got 4 from this. So again, question 1. This is a val, so this is a variable that's pretty much a box that contains this. So if I put question 1 here, in these parentheses, it's pretty much the same thing as 12 modulus 5. And we'll get the same results. We'll get 4. Run 4. And then we can have things like question 2 equals 10 times 5, for example. 50. Go. So you can see that these vals, which are variables, are boxes. They're pretty much boxes that contain a value. So what happens when we want to change one of those values? So we can do question 1, which is 12 modulus 5, which equals 2. And we could do question 1 plus 2, right? That'll equal 4. So what this is doing is question 1 equals question 1 is our 12 modulus 5, which is 5, and then we're just putting 2 plus 2. So we're changing question 1, what it equals to. The problem is val is a value. It cannot be changed. Vals cannot be changed at all. They cannot be added, and they cannot be changed. But there is something that can be changed. That is a var, a variable. So we can see now we don't have that red squiggly line. See, when we put it back to val, we hover over this, val cannot be reassigned. And this IDE, this editor, is very smart. It knows when you have a val and you're trying to change it. So whenever you have a problem where it says a red squiggly line, click on it and press the red light bulb, and you see make variable mutable. What mutable means is that you can change it. So a var is mutable. So var equals mutable, val equals mutable. So mutable equals it can change. Immutable means it cannot change. So when you have a math problem and you specifically want it to change, so you want to add things to it, you want to change it, you always put it for var. But if you have something like your name, you don't want that to change. You don't want ever want that to change. You don't want to change Ted to Ryan or some other name. You don't want the ability to change your name to Dylan, for example. You want it as Ted and you want to keep it as Ted and not change it. That's why we have the val. Now that we know what variables are and we know how to print lines onto the screen, we're going to have the computer actually greet us by our name. We're going to create something that says what's our name. We're going to have a print line that just says what's your name. And then we're going to get user input. So we're going to have the ability to place our name inside of there, and then it's going to tell you what your name is. So again, we want our name to not ever be changed. We want a val. Vals cannot be changed. Name equals, and there's a fancy function just like print line. There's tons of functions, and there's one function called read line. What that does is it takes your input from here and it turns it into this variable name. And we'll show how that works by printing that out. By putting the variable in a print line, and then it will print that variable. So again, we run it. And we see, oh, what's your name? And we click on this, and then we have this blinking cursor here. We can put in Ted. It's green, that means we're inputting something. We press enter and just print out Ted. So this variable name with read line just read what we inputted. As soon as we pressed enter, it put it into this variable, and then we printed it out with print line. But now we can greet ourselves, say hello there, and now we're going to do something called concatenation. We're going to add our name. So what concatenation is pretty much we're taking hello there, and then with that plus sign we're just adding the name, so it'll be hello there Ted. Play this again. We see what's your name, but Ted, just hello there Ted. Now we have a greeter, but we want to add more to this. We want where we input it to be at the end of this line. And how we do that is we can change this print line to a print instead. What that will do is instead of printing and then going to the next line, it will stick at the same line, and then it will append to that line, and I'll show you exactly what it is. See how Ted is right under it? What print line does is it says, what's your name? And then after it does that, the line part, the ln, just goes to the next line. We have what's your name. Now we're near the question mark, no matter where I click. Over there. You put Ted. Hello there, Ted. And add more of this, we can put in there and a space to kind of tell that you need to add some input there. Ted. Hello there, Ted. Now we have a greeter. Now we're getting into types. So we have a value of number equals 2. And these quotation marks specify that it's a text, a string. And that's a problem because this is a number. It's not a string. It's not supposed to be a string, but this is making it a string. And the problem with that is if we have a variable of answer equals number times 5, get an error. We get this red, turns red, and we have an error. It doesn't tell us how to fix it exactly. It just tells us a whole bunch of things, but what we can't do is we can't multiply 5, which is a number, with string because they're totally different types. We need a number times a number. So to do that, we need to take off quotation marks, and we automatically changed the type. How do we know what type it is? Well, if I put quotation marks on string, and remember these args over here on the main. What this means is when you have this, it's pretty much means that you have a type array string. Now that's a bad example. You won't know what an array is, but we can take this number and follow that. So we have a variable number of type string. So again, a string is a text. It's like a paragraph. It's like a document or a Microsoft Word. It's a string. It's text. Now we can change this. Now it's a number. But when in programming, it's called the integer. An integer is pretty much a number. So now it's complaining, saying the integer, blah blah. So it's saying that it's an integer. It's not a string. And we can go here and go to this light bulb here, change type of number, and we can see that we have an int now. So we have a variable number of type int. And we can see now that we have our two ints here. A 5 is an int, 2 is an int, a 10 is an int, a 2000 is an int, and string would be anything in these quotes. But if you want to do things with decimals, well, those are called doubles. Number. We want something like 10.6, right? Now what does that equal? So we can go here, we can put in, but this isn't an int because an integer is just a regular number. It's just 2, 4, 6, 22, 42. It's not 2.2. this is, it's a double. So if we change this to a double, that what a double pretty much is we have numbers on the side and then numbers on the right of a decimal. So if we put this decimal number in here, say we change this to an int. Well, now this can't be an int anymore because what this equals to is like 30, 32, 33.4, something like that. 32.4. 31.8, but it's not an int anymore. It has a decimal in it. So we need to make it a double. And we can also print this out. You can see the double, because it will have decimal in it. And we can see here we have 31.7997. Now, there is another thing that has a decimal in it, and that's called a floating point, float. For it. Change this to without telling you, I'll just show you what the difference between a float and a double. Now here we have a decimal number and it's a double. Now we want a float, so we need a float number. Problem with that is that it doesn't do the same standards of just putting a dot. We need 10.6. Let me just put an F afterwards. I'm not sure why you hit F, but you would often get confused between float and double. So the float you have to put an F after. So you put float number, and this is the only difference between these is one's a float, one's a double. If we run this, we'll see the difference between a float and a double pretty clearly here. We can see that a float is much smaller. It's less accurate than a double. See, it's pretty much almost half. That's pretty much the main difference between a double and a float. We're now going to learn about if statements, and I think the best way to learn if statements is to see it in practice. So here we have a print line, a print that says what's your level of pain. 1, 3. And we have a read line that turns into an int. Don't worry about the question marks, but we'll learn that in another video. Just changes it to an int so it's a little easier. Then it prints and you'll be okay. We want a different print line to show up on the screen for each different number. So 1, it'll be and you're okay, and 2, 2, you're a little hurt, and then 3, you better go to the hospital. And to do that, we need an if statement. So what an if statement does is we have if, and then we have the parentheses, very similar to how we call a function like read line or print.
in this parenthesis, you say something that equals true, and that will run. So, for example, we can have number equals 1. Now you may be thinking, what does this equal mean? These two equals mean. And when you have number equals 5, we're changing the value of number 5. Get that because we have a squiggly line under it that's saying we need a var, that we're changing the variable. But here, on the double equal sign, we don't have a squiggly line because it's not changing the value of that variable. When we have double equals, it's saying if number equals 1. We're not assigning 1 to number, we're checking if number equals 1. And we can go and have our block here, and whatever that's in here, so if number equals 1, this will run. Anything in here will run. So for example, copy that in there. Run this. Say we say 2, nothing prints. We run it again, say 1, this you'll be okay because number does equal 1, and then it ran in these blocks. Alright, it's a little harder things. We can say, so you learned in a math class maybe a very long time ago that we have, greater than and less than. So 1 is greater than 0, for example. We can do that same thing here. So if number is greater than 1, that and the, again, don't worry about these. I deal with that in another video, but I had to change something really quick. So we have if number is greater than 1, and you'll be okay. So if the number is greater than 1, it'll run this stuff in this block. So if we put 2, say you'll be okay. But if we put 1 or lower, it won't print. Now if we want 1 to run, if we want greater than or equal to 1, you just put equals after it. Looks like a frowny face. So if we put 1, say that. We put 2, it'll say that. It'll say 3, we'll say that. We want. Now another thing is that number equals 1, that's true. And if we have something like, we put 1 and we want, if we input 1, this equals 2, that'll be false. So in theory, if we would put true here, it should always run. If we put 0, if we put any number, it should run because all this does is check if is true and print line. This is called a Boolean. You can do the same thing. We have a type of Boolean. that in there, we can have number equals 1. And that is the same exact thing. A Boolean value, it can only be true or false. So this if statement is checking if this is true or false. So 1 1 equals 1 would equal true. 1 equals 2, and you put in 1 would equal false. Now we have more things. We put this back. We have something called else if. Which is pretty much another if statement. Now you may be thinking, why don't I just put another if here? And what that is, I mean, if you put another if, they'll run twice. So, for example, if you have this, it'll run twice. If we have greater than 0, it'll run twice. Same thing, but if we put an else if, what an else if does is it pretty much says if number equals 1, it'll print this. And then it will just skip this else if and go down here. It'll say, oh, well, you know, I found what was true. I'm done. Let's get out of here. We can see that. That's in here. But 1 greater than 0, it'll say, it'll be okay. And it skipped this because it said, this is true. Do this, but just don't do this. And we have also something called else. This doesn't have a parentheses around it. It just says if number equals 1, it'll run this, but if it can't find anything that it equals to, we'll just run else. Dying. Okay. So if your pain level is greater than 1, you're dying. Cool. If we put 1, you know, you'll be okay. If you run it again, we put 2, you're dying because it's great. This isn't true, so it says, oh, well, there's no true ones here, so let's just do else. But if we put 2 or 3 or 4 or 5, this is going to print either way. So if we put else if number equals 2, yeah, you can put are you okay? Now, if the number equals 1 or number equals 2, it'll say something. On number 1, it will say, and you'll be okay. Number 2 will say, are you okay? And then if it's 3, 4, 5, 6, 10, 20, -1, -2, it'll say you're dying. 2, are you okay? We put 3, it'll say just dying. Then we can just put another else if. 3, and then put an else of I that's not between 3. Because if we already have 1, 2, 3, if it doesn't equal those, it's not between 1 and 3. That's how you do if statements. We're going to create a program here, and we're going to have the computer ask us what type of ice cream you want, and it's going to output what price the ice cream is. So in this text file, we have vanilla, that's 120, chocolate is $2, and cherry is very expensive, apparently, it's $12. We're just going to adhere to that. First thing, we need a greeting. What ice cream would like? Put it at print. And that's a string. Now we have the ice cream that we picked out. Put it as line. And don't worry about those double exclamation marks. Now we're going to see if ice cream equals vanilla. That'll be 20. Let's see if that's ends at that. Yep, we have vanilla. That'll be 120. Now I'll show you why we don't we'll do an else if cream equals chocolate bucks. That'll be $2. Want cherry as well. That'll be very expensive, price of $12. We have cherry, that'll be $12. All of them are working. So say we want also banana. It's also the same price as 120 as vanilla. So we could put another else if. And then do that. That's kind of a waste of space. So we're gonna put these I think they're called pipes. Not exactly sure what they're called. But they're right above the enter button. Slash, you just press shift and you press that twice. And this pretty much just means or. So if ice cream equals vanilla, or ice cream equals banana. That banana. Put in banana, it will be Yep, we have 120. If we have something like $2, we can add that to the chocolate one. There we have it. We can also do if one thing equals something or if something equals that. So one can be false, this can be false, but they can't both be false. One has to be true. So if ice cream equals vanilla or ice cream equals banana, then we'll run this. We're going to prove that all of these ifs, these if statements with when. So with when, it's a little cleaner to create. We have when, and then we have our condition, which is ice cream. We don't say equals equals vanilla. We just put if when ice cream, and then we put our conditions. So when ice cream equals vanilla, do this. That'll be 120. Right, so what's going on here is that we have a when statement saying when, and we're putting in the condition of ice cream. So when ice cream, when ice cream equals to vanilla, and then the arrow just means do this. It just points to, when it equals vanilla, do this. What happens if you want more than one of them? Well, you would just do the same thing. We'd put chocolate, for example. Print line, and that'll be $2. Another one, cherry, which is the most expensive one. That'll be $12. Now, can you see the problem with this? We can only do one thing at a time. If we try and do another thing, it's going to be confused. What we have to do is put these brackets in here. These curly braces instead. What this does is when ice cream, not vanilla, when ice cream equals vanilla, do this, but inside of a block. So we can do multiple lines. Enjoy your vanilla. Right? We can do more than one line when we do that, but we have to put in these curly braces. We have to do that. If we don't, it's only expecting this line. We have to put those in, and those are the difference with when and how to use when. Now, when is cool and all, and it makes it a lot easier to read, but there are some drawbacks with when. One of them is we can't put this fancy or here. We can only have one condition at a time, so when ice cream equals vanilla, we can't do that. Also, we can't have, a greater than sign. those can have a greater than sign or a less than sign. We can only have equals. And that's it. Those are the disadvantages of when. We can't have an equal, we can't have a or, and we can only do equals. We can't do greater than or less than, because when only takes one condition and then says when ice cream equals vanilla, when ice cream equals chocolate, it's not greater than or equal. You can't put or high or anything, it won't work. So when is very limited. It's only for very simple things such as if ice cream equals vanilla. And you can see here that it's a lot cleaner. It's a lot cleaner, but we have to write all the other code for banana. So if we put, for example, banana, we have things that are doing more than the same thing. So we have vanilla and banana, they're printing the same exact thing. You have to do that for all of them, and that adds up if you have a lot of ors in there. So it should be something that's very simple, like this. So it won't have too many ors or ands, and it doesn't have greater than or equal to, then use when. If you need the ors, or the ands, or you just need a greater than or less than, use the if statement. A list is something that we can hold multiple things into one variable. With that, we can have strings, ints, doubles, anything we want in that list, and we can have multiples of those into one variable. For example, we have names, and say we want more than one name, we need to create a list. And to create a list, we can do list of. Now you see these, what these called are, but this is called a generic, which is we have a list of, we're naming what we're putting as what type of variable we're putting inside of the list. So we're going to have a list of string. So with this, we have a list of string, the type. And we're putting the names into here. So I'd put Ted, Billy, Ryan. We have our names inside of here. Now this is a list. This is going to look a list of names. This one being the first, this one being the second, this one being the third. But lists don't work that way. The first value in a list is 0. So this is the 0th place of the list, this is the first place of the list, and this is the second of the list. And I'll prove that to you by saying I'll get the first value of the list. So when we want a value from our list, we have to do names and then put in these brackets, then put in the what's called an index. So Ted would be index 0, Billy would be index 1, Ryan would be index 2. And if you run that, it'll say name Ted. Okay, we now have name Ted. We can also get the variables a different way. We can get them through .get as well, and also get 1, and we'll get Billy instead because Billy is index 1. the list because it goes 0, 1, 2. We can also see if the list is empty. So let's see if it's empty. Is list empty? And let's see. We just do names.is empty, and it will give us a true or false value if it has names in here. Of course, it's going to be false because we have Ted, Billy, and Ryan. It's not empty, we have values inside of there. But if we delete all of these, as we can see, it's false here. If we delete all of these and run this again, it's going to be true. So now this is our first error. It's an index out of bounds error. You don't need to know exactly what this means here. Most of the time, I don't know what it means because it's a little complicated. But just look at over here. It says empty list doesn't contain elements at index 1, and that's correct. Our list is empty. Let's just get rid of that right now. We had an error. We were trying to get index 1 and we got an error. And we can see that the list is empty. We did the is empty and it equals true. We're now going to try and print all of these names out onto the screen. For example, we'll do hello names 0. Let's try and copy this 3 times. Okay, we have all our names. It's going to print out hello Ted, Billy, and Ryan. Here, but what happens if Ryan wasn't there? We would get an error, of course, because Ryan isn't there. We can't get index 2 if it isn't there. We're going to get some type of error, and yeah, we have a array index out of bounds exception. What that pretty much means is that we were trying to access index 2 and index 2 doesn't exist. So how do we go against that? How do we do a loop of these of this list? Well, we have to do something that's called a for loop. We can make this a lot easier than just print line 3 times, or if we have more values within our list, we don't want to print each one. We would have 20 lines of code. We can do that in a few lines of code with a for loop. What a for loop does is it pretty much just loops around all of the values within a list. We can do for. We can do name. Now you may think that I'm misspelled names, but we are going to get that into a second. What we're doing here is we're taking names and we're getting each individual value on them. So Ted, Billy, and Mandy. And we're naming it to name. I'll show you what I mean right here. This will make it seem a lot more, make more sense. So we have hello, Ted, Billy, Mandy, but I never put in index 0, 1, or 2. That's because name, what this does is it takes name and it takes the first index over here. It says hello, Ted, and then it gets down to here, and then it goes back up. Now it's index 2, and it says hello, Billy, goes down here, and then loops around back up here, comes down here, and then says Ryan. And to kind of prove that, we'll say looping times, we'll say sum of times looped equals 0. We'll take our number of loops equals number of loops plus 1. And since you var instead. What this is doing is every single time this is run, it prints out the number of times it looped. And then adds to it. And prints it out. I forgot here we have to put in number of times looped, and let's run that again. Yeah, we now have we see that it says hello 0, hello 1, and then hello 2. So what this did is it looped around every time each index. Where essentially what it's doing is it's starting at the line 1 over here, goes down, and then once it's at the second line, it goes back up here until it reaches the end of the list. Now we're going to create a list of our best friends, and we're going to print that to the screen. The first thing, we're going to have our variable with our best friends, so we're going to create a val mainly because we're not creating an entirely new list. List of with type of string, example like Ryan, Ted, and we're gonna put one more name, and that's, put Dylan. And now a for loop, we're going to put friend in as friends. Now we're going to print each friend. Now we have all our friends printed out. That's the downsides of lists are they're only readable. So you can't add things to this list, you can't delete. So if you would want to add a friend, you can't do that with a list.
if you want to delete, you can't do that with lists either. They're really only read only. But you can get around that with using array lists. So array lists, you can add, delete, you can get a value from an index. You can do everything with it that a list can't do. So we're going to change this code to an array, and we're going to add things to it. We're going to delete that, and we're going to create our best friends again. We're going to put string, put Ryan, Ed, John, and Dylan. And we'll see if we run this, we'll have the same results over here. But now we can do best friends, and we can add to it. So we can do best friends to add, and we can add something like we can put in Mike. Run that again, and then there'll be Mike at the bottom of the list. As you can see, Mike is on the bottom of the list. When you add things to a list, they append. So what that means is it gets added to the end of the list every time. Now you can put this in a certain index. So if you do add, there are other ones we can specify the index and the element as well. So we can put add as the 0, 1, put as a 1. But Mike, we'll see, Mike will be here. There we go, Mike is on the first index and actually pushed Ted forward because Ted was number 1, it just pushed it forward. It doesn't push it backwards. Now we're going to get the user's input, and we're going to add to the best friends through the user input. We're going to say, what's your best friend? We're just going to have only 1 on here. Actually, we're going to have none on here. Actually, only 1. And we're going to put best friend input. Get our read line. We can get the user input. Then we're just going to best friends, add best friend input. Now what we're doing, let's space these out a little bit. What we're doing is we're creating our list with our best friends, which is only Ryan. A print line says, what's your best friend? And we get the user input that says, you know, your best friend would be Dylan or Ryan or Michael or something like that. And then you are adding to your list. And don't worry about the exclamation marks. I will discuss those in a later video. Just put those in there. And don't worry what it actually means just yet. And then we're iterating. We're displaying all of our friends within the list. What iteration means is that you are looping through the entire list one at a time. That's what a for loop is. It's iterating over a list. Put best friend and put Mike. And now it spits out Ryan and Mike. One problem here is that we can only add 1 best friend to our list. What if we have more than 1 best friend that we want to add? Well, we could loop this in a for loop for a certain amount of times, maybe 2 or 3 times. Then you're stuck to only 2 or 3 friends. What you could do is do something um, to have a never-ending loop and only break out of it if you enter nothing into the input. Well, to do that, there's something called a while loop, which a while loop pretty much is it says I will loop on forever until this condition isn't met anymore. So to do that, to put it over here, I'm gonna put while. So this is a loop. So we have, the curly braces here, and same thing as a for loop, except we put a condition that's true. So we're gonna put best friend input. It doesn't equal nothing. So if we just press enter, it will give us this return when we input a best friend. Now this is red because best friend input isn't created yet. So what we have to do is create this variable up here. Going to make it a var because we are changing it now. Best friend input. We're gonna put the string, and we're just gonna put nothing. Change this. Changing it now instead of creating an entire new variable. Right, there we go. And now we can see it in action. So now we have what's your best friend? Put Ryan. We have 2 Ryans. Put Mike. We have 2 Ryans and a Mike, and Dylan, Sam. So now we have Ryan, Mike, Dylan, Sam. And we can just press enter and it closes it. What it's doing is let's play it again, and I'll show you what exactly it's doing. So now we're here, we're at what's your best friend, we're right here in the program, what's your best friend, I'll put Mike. When I press enter on Mike, I get the input, I add it to the list, I iterate, remember that fancy word iterate, we're iterating over the list and displaying all the names. And then what it does is, same thing as a for loop, it goes up here and checks this, but it checks it in a different way. Instead of just looping until a number is met, this has to be true in order for it to run this. So when it goes over here, it says is best friend input, while this variable does not equal just no characters, no text in there, then run this. But if it is nothing, so just nothing, just say enter, then skip it and go down here. We put Mike and it runs it again. We put Dylan and it runs it again. Because it's not nothing. I put something in there. This variable has something in there now. Now if we put just enter, what happened now? It went to the while loop after this line, went over here, and said, well, best friend input does equal nothing. this is false. And it goes down here and says, I'm not going to loop this anymore. This is false, it's not true. I can't loop something if it's not true. And it goes on. And that's the while loop. We're now going to give the option to delete a friend in our list. So this, we're going to have to create another option within here because we're only creating more best friends in here. So we need to create another while loop. And we'll just create another one saying, and we'll give two options. Option 1 to add a friend, option 2 to delete a friend, and then option 3 to exit the entire program. So we'll say option picked. This will be an int. Actually, we'll put it as a string. Put it as 1. And we'll say that while we'll go through this loop while the option picked doesn't equal 3. If we put 3, then that exits out of the loop. Put our curly braces in here. Now we have our loop. And we'll say we'll only run this loop if it's 2. Equals 2. Because 2 is going to be to add friends. There. And we'll put in our print statements here. Option number 1 is to delete. Actually, option 1 was to add friends. We'll put this as option 1 instead. And line 2, delete best friend. And line 3, exit. And then we'll have we'll change the option picked equals readline. And we'll hover over this because there's a squiggly line under it. We'll label and say no asserted. We'll learn more about nulls and what this means in a later video. We're just going through more basics. This is more advanced. So now we need to play this and see if it worked. See how we can build upon this and make it better actually. So now it's saying, should we add a best friend, delete a best friend, or exit? I want to add a best friend. We only have Ryan. We'll put Dylan. And we have Ryan, Dylan, what's your best friend? We'll press enter and we'll go back. So what happened there is what we did. We pressed 1, went to add a best friend, so it did this loop. We exited here, and we're still going through this loop because we didn't exit out that one yet. We have to press 3 to exit out because the option picked needs to be 3 to exit. Now we'll do 2. 2 isn't implemented, so it's just going to do the same thing. We'll implement that right now. Else if option picked 2, and then we'll remove which one? We'll put in name of best friend. We'll put this as a print so it's on the same line as what you're your typing. We'll change the best friend input to, actually we'll create another one. Delete best friend input just so it's different. Let's do another nothing. And we'll have this delete best friend input equals read line. Points right here. And now we'll delete our friend after that, so our best friends. And now we'll do remove. We can either do remove of a index or index. We can either remove a index value, so 1, 2, 3, 4, 5, 6, or 0, or we can remove by their value. So we can remove Ryan, and it's smart enough to say, I know Ryan's at index 0, so I'll delete index 0. So we'll just put delete an input, and we'll change the N, proper N, a capital one. And that. And now you run it. It works. Now add best friend, which is 1. We put in Dylan. We have Dylan. Press 2. Name of best friend. Put Ryan. Now add best friend. We'll put Chris. We'll capitalize that Chris. Okay, now we see an error here. You see that there's no way out of here. There's no way that we're gonna get out of this. So now we see a bug in here, and the bug is that we have this while loop as our best friend input, and it's no text. It's a blank text here. So whenever we are coming out of this loop, out of not adding a best friend, we're pressing enter, putting in nothing, and then next time it comes through, it's still nothing. So it skips it every single time, no matter what. So at the beginning, we need to add this new nothing to it. We need to pretty much reset it. So best friend input equals nothing, and that should fix that. And we're going to move our for loop. I think it makes more sense to put at the end of this loop. And a little cleaner. And there we go. I'm gonna run that, see how that goes. All right, now we're going to add a best friend. Remember, we already have Ryan in there. We're going to add Chris. Press enter, we have Ryan and Chris. We're going to delete a best friend now, and we're going to delete Ryan. Woo! We only have Chris, and that actually worked, and we now only have Chris. So we successfully deleted one from the first index by only putting in the name of them. Now let's try and do it by the index. So when you have to do it by the index, we have to do remove at to do the index.
and we'll put delete best friend input. Remember, we have to do it .toInt, and we'll change this what index isn't your best friend anymore. So now we're going to add another best friend. Remember, we still have only Ryan in there. We'll add Chris again. And we'll delete another one. And let's say I don't like Chris anymore. But one. Now I only have Ryan. We successfully deleted one from an index as well as the value. When should you use a for loop or a while loop? So with our last program, we created a best friends program that used a while loop. So why did we use a while loop? How come we didn't use a for loop? We used a while loop because we didn't have a predetermined amount of times we wanted to loop over. You should always use a while loop when you're not sure how many times you want to loop over. That might be because you need user input to stop it, or some other way, maybe some other task that closes it. But for our instance, a while loop, you should always use a while loop when you're not exactly sure how many times you want to loop over, whether that's 10, 20, 40, 50, you're not exactly sure. With a for loop, for example here, we do have a predetermined amount of times we want to loop. We want to loop twice because the array is only 2 indexes, 0 and 1. We know we have only 2 elements, so we know we're only going to loop twice. It wouldn't make sure to do a while loop because a while loop is only for when we don't know how many times we want to loop over. With that said, use a while loop. You're not exactly sure how many times you want to loop over, whether that's from user input you want to stop the looping or something else. And a for loop is when you know how many times you want to loop over, whether that's 2, 4, 6, or 8, 20. We're now learning about functions. A function is very similar to that of a variable in that it holds something. So a variable holds a value. A value can be a string, an integer, or a boolean, or a lot more than that. A function doesn't hold a variable or a value. It specifically holds lines of code. With that, it holds lines of code. For example, we can put this into a function and it will run that. It's kind of like a box similar to a variable, but it holds lines of code instead of a value. Let's get started and see what I mean by that. First thing, we're going to create a function that will print out to the screen these 3 lines. But why would we create a function for that? We would create a function for that so we can only do it in one line. For example, this read line is a function, and if we do a control click on that, we go to that function, and we can see that this read line does something with read line. So this read line function is running this piece of code. With a function, we can have either a question mark or we can have the curly braces here, much like our function here. Our function main has curly braces. We can only have question marks if it's one line, but we also have print line, which we can see it's a function with the fun word, because functions are fun. We have the curly braces, and we have the system.out, that print line. That's the code that's being run inside of the function. Instead of me having to put system.out in a print line, I just put print line here, and it does that for me. Now let's create our own function. So we start with the word fun, short for function. They're also fun. We have to create our greeting. Display greeting. Have a really long name for that shows what it's doing. Copy that. And then we're going to do exactly what we do with reline, for example. We're going to display our display greeting and then run this and see that it works. We have, hi, my name is Kotlin, I'm the computer. What's your name? My name is Ted, and it greets me. We're going to create one more function. Going to mimic this print line. But instead of just putting this print line, we need to pass it something. We need to pass this a name, because this print line isn't going to know what the name is. And I'll show you that. Display name, and we're going to pass in what's called a parameter. Whenever you want to pass in something into a function, such as a variable, what this does is it lets the function know what name is. So in here, in this function here, we don't have access to name, and I'll show you. We don't have access to name at all. That's because everything in this function can only be accessed within this function. Everything inside of this function can only be accessed inside of that function. And the only way to use a function that's not inside of the only way to use a variable that's in here, that you want to use in here, is to pass it through instead of these parentheses. For example, in this print line, this is a parameter. We're putting in a string. We're allowing print line to use that string. For example, if we control and click on it, we can see that we have a function of print line and a parameter of message, the type of any, meaning that it could be int or double or string, anything like that. And we have our what it's doing. But we see here the parentheses, we have a parameter name of string, that's a variable. So when this message is pretty much a variable inside of here that can only be used inside of this function and as a type of any. Let's create our own function with a parameter. Function display name. We're going to create our first parameter with a name of name, variable name of name. We want it as a string. So function display name with a parameter name of name, which value is a string. We're going to print line. Your name is name. And great. And this, we see this squiggly line here, and it says type mismatch required string, and it found a string with a question mark. Put that question mark there. You don't need to know what a question mark is yet. We will get to that in a later video. And now just play this. Let's see if it works.
My name is Colin. I'm a computer. What's your name? But Ted. Your name is Ted. Did it twice because I had this print line here, and we'll do that again. Here we go. We have our greeting here. Putting Ted. And we have your name is Ted, and it worked. We have our first function that has a parameter in it, and also one without a parameter. Now that we have the fundamental grasps on functions, we can learn what this read line does. What this read line is doing is it's running the function, getting the user's input after he presses enter, and then somehow that input is being dragged onto this variable name. How's it doing that? So when we control and click on this, we can see we're doing the function a little bit differently. We're doing it with the equals sign. You can only do that if it's a one line, similar to in here. We can do that same thing. I like the curly braces better. Looks a little nicer. But we can do that. And with this, when you have a colon here, this means return type of string. So we have a function of a read line with a return type of string. So this is saying when you pass it into a variable, so a variable name equals a read line, that gives it the ability, and it tells a variable saying that I'm expecting a string. Then you're kind of just returning a string. Very, very similar to here. This is a little easier. We have our function read, and it's returning. Returning means I am returning this value to this function to give to that variable we're giving it to. So this return would pass up to the function, then return it to this variable. And I'll show you what I mean. It will create another variable here, and an answer to a math problem will create. Do complex math problem with parameters of 4 and 5. Create a function of complex math problem with a variable name of num1, parameter name of num1 with a type of int, and a num2 of type of int. And we'll do a return, just like in the read here. We're returning something. We're just going to return num1 plus num2. That's our complex math problem. We can hover over this and see that type mismatch required. Unit found int. What this is saying is that a function by default has a return. It's expecting a unit. What a unit is thin air. It's nothing. It means nothing. It's a type of nothing. It's nothing pretty much, and it's expecting nothing. So when it's expecting that you're not returning something, you can have something of units. So for example, it's a type. So we can have a type of unit, and unit is pretty much nothing. It's thin air. It's nothing. So it's expecting nothing as a return statement. We have to change that with the return of the colon here and then int. Or we can click on here, hover over a little bit, and go to the light bulb and change return type of enclosed function. Change return type of function to int. I would recommend to type that out, at least at the beginning, just so you remember how to do that, because you will be doing that a lot.
Now we're going to take that variable and print that out. Now again, with these, I want to make this clear that these variables inside of here, these parameters, are only accessible inside of here. When you create a variable such as number, it's only accessible inside of here. Inside of a function, when you create a variable or you have a parameter in there, it's only available inside of that function. It's only available inside of these curly braces. But this number, it's not accessible inside of here. You can't get the number because it's only accessible in its own function. We play this, we'll have our math problem solved. Put in Ted. We see your name is Ted, and the answer is 9. Have that correct, so our function worked. We're going to do another one. Instead of display name and have it do the problem for us, we're going to return user greeting, and then we're going to take that user greeting and print that instead here. So we're just going to return a string. It's going to be a type of string. And by the way, these parameters are these return types for these parameters are mandatory. They're not like the variables. It's mandatory to specify the type for a parameter. For the display name, we're just going to take out the print line over here and do a return. And right there, we have a return right there, and we hover over this, we see required unit, found a string. So what this is saying again is the function is expecting a unit. A unit again is nothing, it's thin air, it's nothing, and we found a string, we're returning a string. Change that to a string. Run this and see if it works. Put in Ted and it worked. Your name is Ted. There we go, we have everything completed. We now know how to do functions and we know how to return them and put parameters in them. Now that we're aware of functions, we can now get started in object-oriented programming. What object-oriented programming is it allows you to create objects. So an object would be very similar to that of a variable, but it's much bigger than that. A object holds variables, it holds functions as well, it holds data, so it holds variables and functions. And a class can be custom, so with object-oriented programming, you can create classes. These classes are objects, so an object or class can be a car, or it can be a TV, it can be a phone, it can be a house. An object is an item. If we right-click on Kotlin and go to New, Kotlin /class, we're going to create a class, and we're going to name it car. At the tippy top of this, we're going to put class car just to indicate that it's a class, and we're going to put it in these curly braces just to say that in this code in here, this is where our class object car is. This is where all the code is. Now if we put var car name, or let's put car name, so you put Toyota, actually manipulate that inside of our
main here. So this is where object comes into play. We can create our car. Now this is a object. We're calling the class car, and we're getting the object of that car. So we're getting a pointer to that car, very similar to a variable in which we are getting the value of that. We're getting the value of car, which is the object of car. So we have a car here. And since we have a global variable, this is a global variable, and a global variable meaning that it belongs in the class level, so it's not a part of a function. So if we have a car function, it's not inside of this function. It's part of the global area. This is seen on the global area. This is seen in the function as well. So functions can see this inside of these curly braces. You can't, if you declare a variable inside a function that is at the function level, it's at a private area. It's can't be seen outside of these curly braces. So remember, if you have a variable inside of a curly brace, it's only seen within that curly brace. But if it's in a class in that curly brace and not inside of the function curly brace, it will be seen outside of that class. So when we call car dot name, or I think it was car name, we're able to get that car name, and we can do a print line, for example. And we can see that we have a car, and its car name, we're able to see the car name Toyota from our main, and we're not even in that class. That's because when we are calling this car with these parentheses, we're actually calling car and saying, give me car and give me all of its variables that I can see. And it gives that to the variable car. We're able to call its functions and its variables within car.carName. So now we have Toyota here. You can also put functions in here, so as make noise. So we can have vroom. We have to put our string there. So if we do car noise, we can now see that we have the return value of vrum from make noise. Here we have vrum. We're now able to create an object from car, our class car, send it to a variable called car, and we're able to call variables within that, and also call functions within that car. Not all variables within an object or class can be seen outside of its class, and we do this for a specific reason. We have certain variables that can't be seen outside the class because sometimes you want them to only be seen within the class. For example, we have a VIN number. Equals, I don't know, that might be a VIN number, or we'll make it a little shorter. We have a VIN number called var VIN number. Let's say that's public right now. We don't want anyone to see the VIN number of the car. Right now we can see it. That's very bad because we don't want to allow other people to see it. We don't want other people to manipulate it. Well, we can always change that by putting in val. They can't manipulate it, but they can still see it. How we can change that is we have to put private behind val, the variable. What that does is it makes it visible only within here, within these curly braces. So if we do here VIN number, we're able to see VIN number and use VIN number within our function here because it's within these curly braces. But if we look in our in here, this isn't part of the class. It says, can I access VIN number? It is private in car. It's only available in car. Another thing you could do, which wouldn't really make sense, is you can actually make this class private as well. This would make this unavailable within another class. That wouldn't make sense in our case, but it is possible to make a class private and only be available inside of this file. This variable now cannot be seen outside of this class, but we can create a function to let it be seen. So let's say we want to get VIN, show VIN number. Let's do that and turn VIN number. We could see it this way. We can do car dot show VIN number, and we'll get that VIN number because what this is doing is we are allowed to see VIN number in this function, and then it's returning the value, not the variable. It's returning the value of the VIN number instead of the variable. And that's how we're able to still see private variables, but that's the only way. Now you know about private variables. We can do more with classes, so we can add things like relationships to classes, and not in that way. We can actually make it very simple to where every car makes a noise, such as vroom. Not just cars do that. So if we have a class called tractor or a class called truck, all of them make a vroom sound pretty much. Why would we make noise to every single one if all of them make the same noise? And we're going to pretty much do that. We create a Kotlin class and we do a vehicle. Class vehicle, and we have a function called make noise, and that's from, and we make sure that's a string. And now we delete this. We go back and we go to car and make noise. We're not able to do a make noise yet anymore because we just deleted from the car. How do we have a relationship with this vehicle where car is a child of vehicle? Essentially, we can call that make noise because car is a vehicle. How do we do that? So same thing with a function where we have a return type. We would do the colon and then vehicle. What this does is it allows us to use all the vehicle functions within that. But we also have to put in open. What open means is that when you open a class, it's able to be extended. So in this class car, we're actually extending vehicle. We're extending the car's features and functionality so that
our car only has a car name, which is Toyota, and then it has a VIN number, is that we're extending the functionality by adding in the vehicle's make noise, which is vroom. And you can see now we can call make noise, and I'll show you exactly what that's doing. It's saying car.make noise, and car is like, I don't have a make noise, but vehicle does. I'm a child of vehicle. I'm extending vehicle, so why not use that one? Goes to vehicle and calls make noise. We can also put in other things. So we can put in a tractor, for example. Tractor. We can extend vehicle because again, extending, we're extending the functionality. We have to put those parentheses in there for an object. Let's say we have, no, we don't have a name. Let's say every tractor is a generic name, like a John Deere or something. And say we have a function that's only specific for tractors, right? I don't know much about tractors, but let's say a roam around crops, right? And then it just roams around crops. It just does some type of action to roam around a crop. Now we have this tractor. Valid tractor. Equals tractor. Now we have this tractor and we're able to make a noise. And we're also allowed to do that roam around crops function as well. So this tractor is a child of vehicle. This tractor can only roam around crops, but since we're extending vehicle, think of this as class tractor extending vehicle. We're extending the functionality, and we're able to call these methods, these functions, I mean, from this class. We're also able to use these functionalities within these cars. We're able to also extend this and then make it further. So we can put in, say we want a machine. We want a machine. We have a class machine, and say we have a function called do stuff, right? Do stuff. Doing stuff like a machine. So now we have to make that open. Now, let's try and get some of these off so it's a little better to see. We have a car, which extends vehicle. So we're able to use the make noise function, but since vehicle is extending machine, we're also able to do stuff because every machine does stuff. So with the car, we're able to do stuff as well. Do stuff because car is extending vehicle and vehicle is extending machine, and you can see how you can run this up and you can make this a lot better. And that's extending classes within object-oriented programming. What if we want to change the car name of our car? We can do that by changing the name with car.name equals another name. We could put it as a Ford, for example, and it will print out Ford instead because we changed the variable name. And we can see that here. We actually changed it by changing the variable. But we can also do it another way. We can also have it so we don't have to do this. We just put in the car name into these parentheses, and this is called a constructor. This is when you create an object, such as a car, and you pass in default, you pass in a parameter, much like a function, but you pass it into the class. So with this variable, by default it's Toyota, but you can change it. But if you have a constructor, you can change that at the beginning. And what I mean by that is we can actually have it to create a constructor after the car. You put in the parentheses right there. And now we can actually create our variable car name. And we can point this to car name this. There we go. Now, with our constructor here, we now have a parameter inside of our constructor. We have it as a type string, and whenever we create a new object, we're forced to put in this car name parameter as a string, and this variable is pointing towards that parameter inside of here. So let's test that out. If we put forward and call the car name, it should be forward. And it's forward, we change it to Nissan. It should be Nissan now. And now you have Nissan. With this constructor, is very powerful. We can change a lot of things. We can change the variable names with this, and we can also change the VIN number if we wanted to. So we can do VIN number param, VIN number param, and we can have a second parameter in our constructor. We can have 1 through 5 and print line, put in VIN number, car.vin, we want this, we're going to make this public for right now. Look at it, VIN number, and let's run it. Our VIN number should have changed to 1, 2, 3, 4, 5 instead of that random number, and we have it as 1, 2, 3, 4, 5. The next video will be about more constructors, so be ready for that. We can also create constructors different ways. This constructor that we already created is a less powerful way, but it's an easier way to implement. We can also create constructors by calling constructor on here and having a parentheses and having a parameter such as car name string, and get rid of this. And now we can actually change our strings. With this, we can have default names for our variables and still have parameters in our constructor. What I mean by that is we can actually change car name from here, and if we have
we have the option to change car name. We don't exactly have to change car name, for example. We can do car name equals car name. And what I just did here is I did this dot car name. This refers to the car. So this refers to the entire class, and I'm pointing towards this car name. This refers to car, so the variable car name is of car this. So this is part of car. I'm calling car name from car. Here I'm calling car name from here. Little confusing, but we have to create a default constructor, so we're going to create it a different way. We can also have multiple constructors with this. And we have error here. And we'll just delete that, and that fixes it. We can also have multiple constructors. We can have 1, 2, 3, 4. We can have as many constructors as possible. And I'll show you why we do that. We can have one variable with no constructor. So let's name this Toyota. Let's change all of these. And now we have a one called Ford. And let's put in Ford here. Instead of just writing that out, we're just going to copy this and change Ford here. And now we play it. With this, we can have different things. So with car, the Toyota, the car name is going to be default Toyota, because our variable here, car name, is default Toyota. And we didn't change it in our constructor. We had no parameters there. So it's going to stay as a default Toyota. But with the Ford, we actually had a constructor. We used the constructor with the car name, and we're changing the car name. And remember, this refers to car. So we're calling car name from car, getting this variable. With car name, we're getting it from this constructor. You can see how they highlight. So if I click this, it goes to the constructor variable. I click this, it goes to this variable. That's an easier way to see where it's going to, that variable. So you can see that we can have multiple constructors. We can also have a constructor for both of them, car name and VIN number. Now we can also call multiple constructors with this, so we can call this constructor we have to do and we can also change the VIN number. Don't forget to put the this. I'm going to do it this way. We have all these variables here, and we have to keep track of them, and we have to change them within our constructor. What if there was an easier way? And there is. It's called a data class, we create the variables inside of our constructor, and that's it. We don't have to create the variables such as here, a global variable such as the car name and the VIN number. We create it in the constructor at the top. I'll show you that. What if we want to create a person? Create a data class, we have to first put data and class, person. And now here is very different. Instead of putting name string, we now put var name string as a variable. And I'll show you right in the tutorial here what that does. We now have a name. For Ted, we can see this the variable name here. But we can also call the person's name here. And we didn't even create the variable. That's because any variable created inside of this constructor is also a variable that's seen. We can edit it and we can see it, but if we put it as val, we can only see it, not edit it. Just like a regular variable. And so we can put age, weight, and we can put in all of those things, and let's put them in here. So age 72 and weight 47. And we can have those other statistics. You have the age and the weight. And we can have both of them without even assigning them, without even putting the curly braces. We don't have to do val name or var name string equals Ted as a default one, and then set it. No, the data class will do that all for you. One of the problems with data classes is we don't have much functionality. We can't. It is a very big pain to change the name in a different way. We don't have as much functionality with the data class. A data class is mainly used just to hold variables. It's not meant to have this a whole bunch of functionality with it, such that you want to call a function and you want to get the name and you want to change the text of the name, and you also want to have a default very different custom things within the class. If you want a lot of functionality with your classes, then do just a regular class in which you can have functions, you can have all these type of things, but a data class is mainly meant just to hold variables. Don't mix the two. You are able to have more functionality with a data class, but data classes are mainly meant to just hold data, hold variables. That's what they should be used for. We're now going to look at interfaces. So interfaces are very similar to classes, except when they have functions, they don't have bodies to them. So they don't have the bodies such as these curly braces. It's pretty much, it just has a function name, the parameters, and the return type, and that's it. So why would you use a interface? Well, there's many uses for interface, but in the first example, we're going to have an interface, and it's going to give this this class a function from the interface, and I'll show you what I mean here. We create a interface, so we put it as person interface. Instead of class, we're going to put interface instead. Person interface. If we put walk, for example, if we extend the person interface to person, we'll have this squiggly line here. If we alt enter on that, implement members, and we'll have walk, and we're able to implement whatever we want with that walk function. We have this to do here telling us that we need to. That's not implemented yet. So then we can do print line walking. So we have that. With interfaces, you typically do that when you want to plan your functions out accordingly for your classes, but you don't want to create those functions just yet. For example, if I wanted to create a talking function, and this goes to all different classes, if this goes to 3 or 4 different classes, it's much easier to just create one function here, and then it gets implemented to all of these classes. And then I can do something like talking. Another use case for interfaces is callbacks. And I'll show you exactly what a callback is by creating one. We'll create another interface called example callback. And we'll put this as callback. And we'll put it as a speak my name, right? We speak my name, and what we can do here is we can create a function inside of our main class right here, and create a function called speak name. And we can actually put our callback inside of here. So callback example callback. We can make that as a function inside of here. And when we do that, we can do stuff like speak name, say, and we have to do this a very different way to put in the callback. We don't create a new object because an interface isn't an object. What you have to do is do this fancy object here, example callback, and then put in your curly braces. And what this does is it creates a object for you with the example callback. And if you over on this, click the magnify this light bulb, and implements that. Now this is called a anonymous inner class, and we'll get to the workings of this in 1 minute. What this is doing is we're passing in example callback into here, and we're actually overriding, which what I mean by overriding is very simple, very similar to how we're doing it to tractor with vehicle, but we're overriding from a interface. So we're borrowing that function. Whenever we call that this function from somewhere else, this will actually be called. And I'll show you exactly what I mean by that. So if we take inside of our speak name, we take our callback, and we say speak my name, and we put in Ted, this will actually show up as, this will actually be called show exactly what I mean. Let me run this. When this callback is run, this callback is referring to this object, this example callback. And when we call speak my name, it's going to run speak my name function here with this custom parameter here. And we see we have my name Ted, so it worked. You would do this if you have certain operations, if you want to get something back, but you don't exactly want to return it. So you don't want to return a string. You want to give it to a callback. You maybe you want to give a series of things, and you can do that. You can say callback dot speak my name and put Ryan. Ryan doesn't deserve to have a capital letter for some reason, but Dylan deserves to have a capital D. So we can call this callback many times as we want. We can call this callback an hour later, 12 hours later if we wanted to, and it would still give us the same results. As with returning, it's call the function and then return the value, and that's it. With here, you can call the callback as many times as you want. Singletons are something that are very powerful. With regular classes such as person, whenever we create one or two objects of that class person, they're both entirely different. So if I have a name of Ted here, a name of Ryan here, they're going to be totally different. Person 1 is going to have Ted, person 1 is going to be Ryan. But at the same time, if we create another person, new person, and we print a new name of that, a default name, that's going to be the default name. It's not going to pick up as Ryan. And that's because every time you create a new object of person that is an entirely new object, they're not the same. It's an entirely new instance of it. With singletons, we tie them all together. Every single one is the same. So if I were to call person 2 and new person, they would both be Ryan. And I'll show you what I mean here. Singleton person. And to do that, instead of class, we do object singleton person. And I just named it, you don't have to have singleton in the name. I just put singleton to make it a little easier. And we can have a name string, and we'll have its default as nothing. And we'll see if, and you can see that it's yellow. It's a different color now. You can see that this is a singleton, and we call it an object. And now we're going to see if it's going to be the same as here. And we'll spread this out. We'll have person val singleton person equals singleton person. Singleton person dot name equals, we'll put that as Ted first. Then we'll have our second singleton person equals singleton person. singleton person 2 dot, and we'll just not put in the name. And now we'll print line both of them. Singleton person. We'll just copy this to make it easier. And we'll see if both the names are the same. Now you can see here that we aren't putting in parentheses such as here when we're creating a new object of singleton person, and that's because we're not creating a new object. We're labeling this as object singleton person because this is entirely one object. We can't create another object. So this singleton object is one object. Not creating new objects, there's only one singleton person. But if you have person and the regular person, which is just a regular class, we're creating multiple objects of that. That's why they're all different. A singleton person is one object, meaning that there is only one singleton person. They're all going to be the same. So if we play this, they are all going to be the same. Not person, but singleton person. You can see that they're both Ted. And that's because it's only one object. Again, we could have done it very differently. We didn't have to create a variable for that. What's pretty cool about this is we can just call the actual class on it. The actual class, we don't have to create a new object because remember here, object means it's already created. So the object is already created. We don't have to create a new instance of it. That said, singletons shouldn't be used all the time. They should only be used for certain things, and that's way more advanced. But just know that you shouldn't be using singletons very often. We're going to be learning about a new class, and that's called enum. What enum is pretty much a class without functions and with only variables that are always uppercase, so they're always capitalized. Every word, and they only hold one value. You can't set the value. I'll show you what I mean here. They're used for only a few things. We're going to have different actions, and I'll show you what I mean. So we have a enum class. We just put enum before class, and it makes it a enum class. And we can create things such as run, walk, and biking. One rule for enum is they should always be capitalized. And if you need two words, such as run and walk, you don't do like that. You put in the underscore like that. What this is just each one is pretty much a variable that run equals a string run, walk equals a string walk, and biking equals a string biking. You would use these for something like an action or an action that can't be changed. So they're pretty much values. So run, for example, in a variable would be. That's pretty much it. Makes it easy to create, and it has more functionality, and I'll show you that right now. So we have a person, and we want to do an action. We want to do either a run, walk, or biking. We don't want to do anything else other than that. And you would think we would do something like action string, but no, we actually put the class name in it because each value in here is can only work with the class name. And so if we put person action, we'll put a default value of walk. person's walking right now, and this action equals action. Got to put this as a var instead of a val. There we go. Now what walk is, if we control and space on walk, we can see it's that of class person action and not a string. When we do something like toString, it equals, walk. And I'll show you a much better example by creating a object of person. We have a person object, and we're going to do an action. And we're going to do person action.biking. We don't have to create the object person action. It's very similar to a the enum class is very similar to a singleton. That's why we don't have to create a new object for person action, such as, we don't have to do that. It won't really allow us to do that anyway, but very similar to a singleton, but it only has values. So if we do something like we print out the action, this will automatically turn to a string. Now action is person action, but when you put it inside of a string, it automatically does to a string, and I'll show you that right here. Whenever you concatenate, this is called concatenation. When you put a plus from a string, or you put it inside the string, it concatenates. And if a method has a .toString, very similar to int or double, it will automatically apply it to that. So this is an object. This is a person action, and it's pointing to which one did we do? Biking. So it's pointing towards a biking one. So if we do the press play, oops, we just delete that. And there we go. Now we have biking. Now we're going to put in after action and before we change the action as well. And you'll see that it'll show the default one, which is walking. Now you may think, well, what is this for? Why do I need this? How come I don't just put in here, biking? Well, we do the enum because what if we're creating a mobile app such as Android, and we have a class for your person, and say you're having a running app, and you want to do an action, and you want to detect whether the person's running, walking, or biking. Well, you don't want the action to be able to do flying or skateboarding if your app doesn't support that. Your app only supports run, walk, and biking. So that's all you should put in there. And this forces your function in here to only support those. Not only that, we can do more things with it. So we can do if person dot action equals person action dot biking, and we can do yay, I'm biking. Or we can do something other than that. There we go. Now with comparing enum values such as biking and walking, you can't do the double equals. It is better to do the dot equals. So if we do else if person dot action equals person action dot walking or walk, boo, I'm walking, this is boring. You know, you can do a lot more things with it. You can have for example, if you're making an Android app, you can say if you're running, vibrate the screen, or if you're running, make the screen turn red, but if you're walking, make it yellow to indicate it's slow. You do a lot of things here. When we have objects, we have values such as var and val, and we can both get the value and set the value, and that's called a getter or setter. So a getter is pretty much when you have a object such as person, and you're getting the value of action, for example. So I'm getting the action variable, action, to my value variable here to AC, or my action. We can also set things. This is called a setter. We can do action equals person action that walk, for example. We can change that. Or run. We never did running. And we can actually change these. So if we want, we can override, most fancy words for today, the getter. So whenever we get the value, we can change that. So instead of getting walk, we can manipulate the stuff and say we don't care. We want to get to run every time. So we can do stuff like, oops, and print out action person.action, and it will be run. It will be run instead of walk. Yep, and it's showing it as run here. Now, with your action, you're equaling it to walk, but it's getting run, and that's because we're overriding, remember that fancy word, overriding, the get. Whenever we are using this method, we are using the get method to get walk, but I overridden the get method and I made it run instead, so I changed that. We also have a setter that we can change. So we can do set value, we can do this, and then we can return, say we want to return only person action dot run every single time we do that. So we can do person dot action equals, let's put as walking, and it'll be run again. This build and now
we do have to we do have to put in field instead of just putting that as the last one. Field is a very weird term. Field is referring to action. You can see once I highlight on it, action is always action is highlighted as well. So field is a fancy keyword in the setter for the variable that you're having the setter on. We now know about classes, private variables, enums, interfaces, and how to extend classes. Now we're going to create our own project, and this is called a bank project. So pretty much we're going to create a bank with depositing and withdrawing. First thing we need to do is create a project. Go to new and then new project, and go to Gradle and then check mark Kotlin. Put in bank into the artifact ID, and remember to check auto imports and finish. Okay, now we go here, and we did this I think the second or third tutorial in this series, so you might not remember everything exactly. I will help you get there. First thing, you need to right click the top file here, the bank, do new directory, and put it as source. We're creating the folders to create our Kotlin files. Source, main, and now Kotlin. Here's where we create our main class. We're going to create this. We're just going to put it as main class. And then function main args, and we put in the array with a string. And with that, now let's just test to see if this is working. Welcome to Ted's bank. Click on this Kotlin thing and the Kotlin logo. And press run and see if this works. Alright, now it works now. We now have a project for our bank app. First thing with a bank, we're going to give it choices to withdraw, deposit, or exit. Now we're going to have our read line, so what we put in. First thing, we need the choice. User's choice equals read line. And we're going to put that as an int. To int. Question mark there. And I like to specify that's int right there, just so I know. Those double exclamation points there. We'll get to that very soon, actually. Now we're going to put in while user's choice does not equal, let's put 3. Number 3 will be, I don't know, the choice to exit. We'll put in our first print statement in here. You're right here. Choose what you want. We'll put it as 1, 1, withdraw, 2,
deposit. And then 3 exit. Great, now we have that, and let's try and run it. Okay, now withdraw. Now this isn't in the while loop, so that won't loop around. Put this user choice over here. There we go. This has a var instead, and there. Run that again, see if it works. I do withdraw, 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 withdraw. Okay, there we go. Now we have our user input, and that part is finished. Now we're going to create our bank class so we can keep track of the money that's within our bank. I click on Kotlin and create a new class, and we're just going to call it bank. Class bank. We're not going to do a data class because we need more than just the variables. We need to keep track of the amount of money in your account. So by default, our money, we'll just put this as money in bank is going to be 0, and we'll just keep we'll just keep track of that as money in bank as 0. And now we'll print line every single time we're in here for the money. Current amount of money. And we'll create our bank here. Val bank equals bank. This as bank dot money in bank. Play this again, and we'll create different functions for withdrawing and depositing right now. And we see here we have current amount of money in bank is 0. We'll create a function. We don't want to just minus or plus this because that's a little confusing. So we're going to create our deposit and draw. So money deposit. Amount int. Money in bank. Oops. I'll keep those in those curly braces there. Money in bank equals money in bank minus amount. Let's get this as a bar. And now withdraw. Amount again. Money in bank equals money in bank plus amounts. Now we can make this a little better by doing equals minus and then just putting the amounts. That's the same exact thing. Equals plus same exact thing. Now we have that. Now it's time to kind of group these together in different things. We're going to put this into one function here as a greeting. So we're going to create another function called
greet user with choices. Just gonna do that, and we're just going to take all of these and put it there. Greet user with choices, and that's really it for that. And we'll put this in a function as well right now. Function display amount in bank. Now we're doing this because it's a lot easier to figure out what this means by just looking at a name of a function rather than looking at, okay, print line, current amount of money, bank, what is that? You don't know what it is until you read this part. So we're going to make it a little easier to understand. Display amount to bank. Then we're going to put bank in here. We can just hover over this, do the light bulb, and do add parameter. It's a lot easier. Place again. Now that this is a lot easier to understand right now. The first thing is greet the user with choices. Look at this, there's choices if you want to look more in depth into it. And here we have display amount and bank. That's explanatory. If we look more, it says this. If we do 3, it exits, and that works perfectly. We now have withdraw, deposit, and exit within our app here, but we can't really do anything yet. It shows how much money you have in your bank, and it's $0, but we can't deposit any, and we can't certainly withdraw any either. We can't have a negative, and that's not even implemented either. We're now going to deposit money into our bank. First of all, we're going to make this a little clearer, the 1s and the 3s. The 1 is a withdraw, the 3 is exit, and a 2 is a deposit, just to make things a little clearer because we will be using those numbers a lot. So withdraw equals 1, deposit equals 2, and exit equals 3. And now we change these, withdraw and exit. We now have after the user's choice, after the user picks a choice of 1, 2, or 3, or withdraw, deposit, or exit, we want to display that information, such as would you like to how much money would you like to deposit into the bank, or how much would you like to withdraw. So we should do that after. So if the user's choice equals deposit, we should get a deposit amount from the get deposit amount from user. It's great, it's perfect, and get deposit, there we go. Did the auto complete right there. We make a greeting now of how much would you like to deposit. Now we're not gonna have this as a print line, we're gonna have this as a print, so it's on the same line. So deposits amount equals read line. Now to double. We have these double exclamation points. We didn't go into this yet, but the double exclamation points is pretty much saying if read line returns null or something that is null, and it can't return a double, it just will return this as null. That's pretty much what that is. We will go into farther, more in-depth things about that in a upcoming video, though. So now we want to return the deposit amount with the type of double. Coming up here, we want to deposit that. There we go. There we go. Now I have here, I changed some things before. Now, here's what you should have. The deposit amount should be a plus, and also they should be separated. It should be plus equals, and this should be minus equals. If you don't do that, it will, if you put in 20, it will stay as 20. It won't add to this. We should change this to a double. And these also to doubles, just so we have the cents as well. We don't want just the dollars, we want the cents. And it should be working now, so let's play. Okay, now let's deposit. Put in $20. Good, let's deposit again, put 100. Okay, it works. We have $120. And the next video we're going to be working into the withdrawing. Now withdrawing now, it's the same thing as the deposit, except we are doing bank.withdraw instead of deposit. First thing, we're doing a else if. User's choice equals withdraw. And we're just going to put withdraw amount equals get withdraw amount from user. Very similar thing, and we're going to create that another function very similar to this one. I'm going to put a double first this time because we know we want a double as our return withdraw amount. Again, put print, don't put print line. We want it on the same line. How much would you like to withdraw? You're gonna put val withdraw amount equals read line to double. There we go. Return withdraw amount. Now out of here, we want to withdraw with our withdraw amount. And there we go. Just going to play that now. Okay, let's test the withdrawal. Let's first deposit some money in there. We'll put $100. Now withdraw. How much would you like to withdraw? Well, we'll take out $20, so it'll be 80 now, and it works. Let's withdraw again and put another 10. 70. Now the withdraw works now. Let's make this a little easier to see. Let's put this all into another function just so it's a little easier to see. And let's name that do bank action from user input. And the user input will be a int, so input, actually we'll put user's choice, and then just, where's this end? A good way to see if a curly brace, a function or a loop where it ends is just to take your cursor and click at the right side of these, and it'll show you the end. Then just copy it. Put it in there just to separate it a little bit. We'll put user's choice. Put that at the top. And we'll also put in the bank as well, just so it has access to the bank. There we go, and we can't do that. We'll just put this as a global variable now, because now we don't have any access to the user choice, because remember, user's choice is contained within this function. It can't go into this function. We don't have access to user's choice because we only have access to these variables in here and also in here. We don't have access to the variables in here, so we're going to put this as a global variable instead. So var user's choice equals withdraw. And then it should be accessed. You should be able to access it anywhere within this class. Take this out. Take that out, so we only give it bank, and let's play this again. Size this and see if it works. So we'll do deposit first, put in $100. Go to withdraw and take out 10, and it works still. Now it's a lot cleaner here. We can see now in the main, we're printing welcome to Ted's bank. We're creating this bank, and then we're just the default. Actually, we can get rid of that actually. So we're creating a bank, and then we're doing do action from user input, and that's it. We now have our bank with our withdraw and deposit. We see this list of banks. We have 2 banks and we have a null. What a null is pretty much nothing. Null is very short term for pretty much nothing, except when you call upon this, we're going to do bank dot money in bank, and when we get to this null over here, it's going to give us an error. And I'll show you exactly what I mean. So if we do list of banks dot for each, do item, and we do what do we need? The money in bank. So money equals item dot money in bank, and then we're going to just do money and money. There we go. Now don't just do the double exclamation point. What the double exclamation point, they call it a double bang. Each exclamation point is a bang, so this is called a double bang. What this means is it's going to treat it as normal. If it's null, it will call money in bank, and it will display an error, and it will crash. So whether this is a bank, this item, or this is a null, it will call this method upon it and get this money. If it's a null, it will say, I don't know what to do, and the whole entire application will crash.
we see here that on here, exception in thread main, colon null pointer exception on KT12. So pretty much line 12, that means. We just click that and we see, okay, it happened here, a null pointer exception. We just got a null pointer exception and it crashed our app. That's because we call the money in bank on a null value. Null value is nothing. It's not bank. It's not nothing. So it doesn't have this method. And we called that upon it and it crashed. We're going to see how we get rid of this error in a very simple way. First of all, we want to have something where we don't call this if it's null. We do that because we can't call a money in bank if that object doesn't have that method, and null definitely doesn't have the method or value of money in bank. So we're going to put in an if statement saying if item equals, doesn't equal null, then we run this. Which pretty much means if it's null, it's not going to run this. And since Kotlin is very, very smart, it's saying that we don't really need this double exclamation point, this double bang, mainly because it's never going to be null. So Kotlin already knows that this isn't going to be null, so why put in this double bang if it's not going to be null? Don't waste the space, don't put it in double bang. This is a great way to see if something might be null. And if we play this, we won't get any null pointer exceptions. And there we go, it worked. Unfortunately, the null kind of passed over, so we're going to put in an else and put in a print line and saying this is null to see how many nulls there are, and obviously there is one, but I just want to check. There we go, we have one null, and that's at the end of the list. We can now see if something is null and then act accordingly to that. We also have another way to get rid of nulls within our application so there is no more null pointer exceptions. Now this, we're checking if an item is null or not, and we're doing these two lines of code if it's not null, and we're doing this if it is null. We can do this in a lot less lines. This does not equal null is greater null, but if you do this a lot, it will show up a lot in your code, and it will dominate your code with does not equal null, and you don't really want that. So we're going to get rid of this and this, and as of right now there's going to be a whole bunch of errors. It's telling us right now it's not safe to do this, to put the double exclamation point, the double bang, and it's going to run a null pointer exception. But we could do something else. We can do a question mark dot, very subtle difference, but it will make a very big difference in the null pointer exception. There actually won't even be a null pointer exception anymore. And we see now that we have money 0, and then we have a money null. What that just did right there was when it sees item is null, and it sees that money in bank, it isn't able to complete that method, it will automatically return null to money. For instance, if we just put that as a string, what is this, a double? I like to name my variables in my models, so that should be a double. Here we go. Now we have something of a problem. We named it a double, But what happens is that if we read this, type mismatch, required double, found double, question mark. What that means is whenever we call money, such as, money dot, let's find something. Actually, we need to fix this first. Put a question mark there. We delete that first. So we test in money dot, let's put like toString or something. That. If we do a method such as money.isNaN, which is short for is not a number, we'll have a very weird only safe or non-null assertion. Whatever. It's just saying that money could be null, saying that this could throw a null pointer exception. You should put a double bang or a question mark because it could be null. It's just the IDE is warning you. And we have that because we have this question mark type. This double and then a question mark is saying that money could be a double or it could be a null. Watch out. And whenever you call a method onto that, we need to check if it's a null. So if we print out this money again, it should be fine because doing a string is going to be automatically null for that. We're allowed to have nulls in strings, such as the same thing we're allowed to have toString because a string can be null at the same time. But we can't call methods that null doesn't have, such as we can't do is not a number on a string, on a null I mean. So it won't allow us to do that. We have to put a question mark on there. I would recommend putting a question mark all the time. Never put a double exclamation point, a double bang, because that will result in null pointer exceptions and it will crash your app. We need our bank to tell us what date it is for each transaction. So we need to figure out what date it is by the month, the year, the hour, the second, and the minute to figure out when that transaction was completed. First thing we need to learn is what a millisecond is and what that forms into to get our time. So if we get current time in milliseconds, we can do a function called system.currentTime milliseconds. That will give us the time in milliseconds. This gives us the current month, the current seconds, the current millisecond, everything, and it gives us a long. And I'll show you what that's going to look like. That's going to look like a big giant number. And that's going to be our date. And we can format it to look human readable. And this is pretty much a very big number. I don't know what the date is right now, and I can't figure that out through that number, but the computer can. And it gets that because this is the amount of milliseconds from now to 1970, January 1st. So January 1st, 1970. From that exact time, this is how many milliseconds it is from now and that time. and that's how it figures out the date by the millisecond. And we can format that into a human readable date by creating a variable and creating an object called date and putting in our current time in milliseconds, and that will give us our date. And we can then do this date.toString, and it will give us a formatted dates that we can't really format ourselves right now, but it will give us a very good starting point of what we want. So right now it's Wednesday, August 9th, and it's 2 o'clock, 2:24 EDT 2017. It's in 24-hour formats, so it's not readable for everywhere, but this is a very simple format. We can change this later on, but right now we just want the date. So we're going to go in our bank, and we're going to put in get current date, and first thing we need is the date. And we're going to put in we're going to have the person put in the milliseconds, just so it's not in here. I don't want it in the method. I want it in here so I can kind of manipulate that whenever I want. Then we have current time milliseconds, and then just return date dot to string right there. And we can change this to a string. And there we go. Now we can uncomment these, get rid of this date, and then whenever we deposit, we can say date and then bank dot get current date, and then put system dot current time in milliseconds. There we have it. Every single time we deposit, it's going to show us our date, and let's test that out. Press 2, we get the deposit, we put in 20 bucks. Yeah, the date is Wednesday, blah, 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 and it shows our date. Next video, we're going to be formatting that date in a more human readable format that we can read it in our country. We now need to format our date. We can get things like years, months, day, seconds, minutes, all of that, and we can format it any way we want. And we have to do that through a object called simple date formatter. And if we go on Google or Bing or whatever search engine you have and you put in simple date formatter with Java, you get this link right here. We go to it, we get the entire docs here. So if we go down, we can see patterns here. So Y represents the year, W represents the week of the year, D, lowercase d represents the day in the month, and go on and on. We have the hours, the time zone, and everything. And we can get all of these through a string. I'll show you how we can do that. We create a formatter with simple date format. And then we put in our format. So we see on here that the year, we give it a lowercase y. Let's try and do that first and put a slash. And then we can do our formatted date, and put in the formatter, format, and then put in our date.
Now what this is doing is this is creating a format. It's saying I want Y and then just a random slash. And then this is connecting the format with the date. And this is actually creating the date. And then we're just returning that. We could just do, to make it less code, we can just do return formatter dot format, and that would be just fine. Whichever you prefer. I usually prefer it this way. You do deposit, put in 20, and aha, we have 2017. So let's try and do this a different way here. Let's put in the month, the day, and then the year, for example. So day in the month, actually, we put in D. We want the month first, though. Month. M. Put an M. So for here, we want 3 letters of the month of the year. We want the day, and then we want the year again. Let's try and put that in again, see if that works. We now have August 9th, 2017. We're going to put in another D because we want a 0 in there. Deposit, put in $20. Okay, now it's August 9th, 2017. Now we want some sort of seconds, and then we'll put hour of day and then minutes. We'll put hour in AM or PM. Yeah, we'll put hour to AM or PM. So 1 to 12. And then the minutes in the hour, so MM. And then AM or PM. And where can you find that? We can find that here with A. You can see if PM or AM. We'll see if that worked. Go to deposit, deposit $20 again. Now we can see we have August 9th, 2017, 2:36 p.m. It's not 2:37. And now we have that date. We now know how to format dates correctly, giving us the month, the day, the year, the minutes, and second, all with this documentation here. And we could put so much more into here, but this is all we're going to put in for a very simple date format. We can do amazing things with lists in Kotlin. One of which is actually filtering those lists down. For example, let's take this list of grades. We can actually filter this list in about 1 or 2 lines of code to find out which ones are passing. So when I took high school, a 65, anything higher than a 65 was passing. So let's see how many grades in there are passing grades. So if we take grades and then do filter. Now, this isn't something that you normally see. Where are the parentheses? You're given this this function type of thing, and we have these curly braces. This is a function. This is a little weird. This is what's called a lambda. What lambdas are is we're given a
a list. A list is pretty much a iterable. If we go into here and we go back, go to filter, go to list, we can see that filter is part of collections and it's also part of iterable. So lists, all lists are iterables. A mutable list, a regular list, a immutable list, an array, they're all iterables. What that means is that they can they go one by one in a list. Now what a lambda is, it's a function that that you have control over what to do in that function. So I'll tell you what I mean. If we go into this filter and we say, and we do control space, Alright, that's not going to work. If we do item and then this, what this is doing is this is a lambda. This is what a lambda is all about. We're filtering this entire list, and this item refers to a single item in this list. What filter will do, it will create another list. If we go to filter, it actually creates another list. And we can create a Boolean value, so saying item, if item is greater than 65, it will keep that list. So if we put val passing grades, we will get all passing grades, and passing grades are items level greater than 65. And we can do that by we can confirm that by doing passing grades and just doing a for each, and again doing the lambda and print all those out. Running it, we'll see that we have all passing grades. We don't have any 40s or the 40, 30, or 20. We won't have those in there. We'll have 70, 100, 80, and 10. And what this is doing is, this is actually doing a for loop on this, and it's trying to make it very a basic sense, but this item refers to every single individual item in here. And that's what lambda is all about. Lambdas are everywhere in Kotlin, and they're very hard to get into at first, but they're very rewarding. We can also do other things such as count. So num items passing, it's grades dots, not gradles, grades dot count. So we can do the same thing. We can do this fancy item and then this arrow point saying that each item variable item is one item in this, and my code goes up to this arrow right here. If item is greater than 65, instead of getting each item in here, this is going to get how many items are over 65. So if we print line num items num to human readable number of grades passing, num items passing, and we play this again, we run this, we'll get the number of grades passing. So now we have a number of grades of passing, which is 4, which is correct. 70, 180, and 70 equals 4 grades that are passing. Lambdas are very powerful. They're very complex at the same time. If we do control and click on count, we can actually see what's going on in this count. And not really looking at this, we can look at this and we can see what's going on. We can see that our predicate, you can't see this directly, but our predicate is this. So think of predicate as item greater than 65. That's what the predicate is. We have our count. We have a for loop with an element. So each item in this, which this refers to the list grades. So for each element in this, if predicates elements. So what this is doing is a predicate is actually creating somewhat of a function. So when we put item is greater than 65, what predicate is doing, and I'll show you right here, predicate, what this is doing is return item is greater than 65. That's what that's doing. And this is unknown because I think this is already taken. Yep. No, that this isn't a variable. This is supposed to be a function. What am I doing? So that's what this in this counts in this lambda function we're looking at. This predicate is pretty much just taking our what we put in those curly braces, putting it into a function and giving it a true or false from that. Very, very complex at the beginning to figure out, but it gets very simple later on. So we're putting item is greater than 65, so our predicate is going to be exactly this. You give a predicate, you give it an item, and it returns true or false with that. Now it says if, and this is pretty much saying if grade is greater than 65, which is our element. If your grade, which is let's say if your element is greater than 65, then do this. And then at the end it returns that. If we can make this a little simpler, we'll copy and paste this really quick. We'll do this, and we'll change element to grade. I'll put another parentheses in here, just to make it a little neater. Again, don't worry about this. We'll look at that into another video very soon. Do we need that public? Okay, there we go. So right here, we just made it a little easier to understand. What is this? Oh, that's count. So what we're doing is we're taking our predicate. So our predicate is item greater than 65. We're taking a for loop into our grades loop. So this equals the grades from your calling method. So each grade, if the predicate, so if your grade is greater than 65, we do the count. And that's pretty much what a lambda is, pretty much. Very complex at the beginning, but gets very simple later on. Later on, after you looked at a whole bunch of lambdas, it gets a lot easier. We also have something called average with iterables. We can actually take the average of all the numbers within a list, very similar to the count and the filter. except we're not creating another list, we're getting the average of all of the items within there. So let's try and get the average of all the grades. And if we do grades dot average, and we put that into a variable, and then we print out the average grade, and then put in our $sign and average grade. We'll now have our average grade there. Very simple, you don't have to do any for loops or anything like that. And it'll give us our average grade. As you can see now, we have our average grade of 52.5, which is correct. That is our average. We can do one really special thing with Kotlin, and that's to create our own functions for classes we don't own. What I mean by that is when we have a class such as bank, we can create our own function like normal and just create a new function. But if we don't own a class such as mutable list, this class is such as that class, we can't create a function in there because we don't own that class. It's not writable, it's only readable. And with extensions, that gives us the power to create our own functions for that class. And I'll give you a demonstration. We can actually create, even though this function isn't there, swap, we can actually create that. We're going to swap 70 and 100. And now we can create that swap function out of thin air right now. And we're going to do, we're going to create that right now with a function. And now when we put in the class, we want to add the function to, and we're going to put in an int. We only want the ints. Then we do dot and then our function name. We're going to put in our parameters just like usual. Put in the curlies and temp index. We're going to swap both of the 0 and 1. So this is wrong. We have to put 0 and 1. So we're swapping index 0 with index 1. And now we're putting the temp index of 1, and I'll show you why we're doing that in a second. And now we're taking 1 and we're swapping it with 2. Now remember with lambdas, the this refers to the class that we're putting it on. So when we're doing swap, we're actually when we're doing swap on this list, we're actually doing, instead of this, we're doing grades too. It's just doing that. It's taking the one behind the period. And now we're taking 2 and we're equaling it to the temp index. This is why we save the temp index, because after we set the index 1 with a different value, we actually lost that value. And now that's done. If we play this, it's going to be 170, just like down here. I did a little test before. And then we'll have a swap of those two variables. And we can do this with many ways. We can do these with arrays. We can do this with strings, with pretty much anything, any class. And let me verify that that it's swapped. Put grade and then print line grade, and we'll play it. Let's see if it's swapped. And there we go, it's swapped, so our first one is 100 instead of 70. We now know how to do extensions.